Hi everyone, I'm Cheryl. In this problem, we're asked to find the gradient of z equals the natural log of the quantity x squared minus y all over x minus 4 at the point 2, 3. Now, the gradient is a vector-valued function, and it's defined as the gradient of f at xy is equal to the partial derivative of f with respect to x at xy times vector I plus the partial of f with respect to y at xy times vector j. Now, one thing to notice is that I can write my equation here as a function and say that f of xy is equal to z, which is in turn equal to my expression. So what I need to do then is to find the partial of both of those. And in fact, what I need to do is I want to find out what the gradient is at the point 2, 3. So more specifically, our formula becomes the gradient at 2, 3 equals the partial with respect to x at 2, 3 times my vector I plus the partial with respect to y at the point 2, 3 times my vector j. So what I need then are the first partials. Now, because my function is a little bit more complicated, I'm going to go ahead and do some side work to get those partials. So let's first of all look at the partial with respect to x of xy. All right, so we're going to treat y like it's a constant. So when I take the derivative, I need to begin with the quotient rule. So I'm going to take x times the derivative of the natural log of x squared minus y. So that's 1 over x squared minus y times the derivative of the inside piece, which is a 2x. Then I have to subtract the numerator times the derivative of the denominator, which is just 1, and divide the whole thing by x squared. And don't forget, I need to take the derivative of 4, but that's just 0. All right, so what do I have? I have 2x squared all over x squared minus y minus the natural log of the quantity x squared minus y all over x squared. All right, now I could do some algebra to simplify this, but remember what I'm really interested in is the partial at the point 2, 3. So let's go ahead and plug in 2, 3. So the partial with respect to x at 2, 3 is going to be 2 times 2 squared all over 2 squared minus 3 minus the natural log of 2 squared minus 3 all over 2 squared. All right, so that's going to give me 4 times 2, that's going to be 8, all over 4 minus 3, that's 1. And this is going to be 4 minus 3, or 1, and the natural log of 1 is 0. So I'll be subtracting 0 and then dividing the whole thing by 4. So I have 8 over 4, or 2. Okay, that's the partial with respect to x. Now we need the partial with respect to y. Now remember, when I take the partial with respect to y, I'm treating x as if it's a constant. So when I go ahead and take the partial, that 1 over x is really just a constant multiple. So I'll just pull that out. And then I'll take the derivative of the natural log of the quantity x squared minus y. So that's going to be 1 over x squared minus y times the derivative of this piece, which is just a negative 1. And then, of course, the derivative of my minus 4 is 0. So I have minus 1 all over x times the quantity x squared minus y. Now again, I'm interested in what's happening at the point 2, 3. So the partial with respect to y at the point 2, 3 is going to be minus 1 all over 2 times 2 squared minus 3, which is going to be a negative 1/2. All right, so now I'm ready to go back to my formula for my gradient. I know that in this particular case, the partial with respect to x at 2, 3, that was 2, so I have 2i. And the partial with respect to y at 2, 3 was negative a half, so that's minus 1/2 j. And that's my gradient. I hope that was helpful. Thanks.